Hey, how's it going? Got a question for you. Are you one of those students struggling to understand the exogenous pathway for antigen processing and presentation? Or better yet, one of those stressed out students trying to cram for that test you gotta take in 20 minutes? Well, no worries, mate. Let me help you out. Let me be that lost voice in the wilderness for a second. For starters, do you happen to know what B cells, dendritic cells, and macrophages all have in common? Well, these cells are all professional antigen-presenting cells that express both class 1 and class 2 MHC molecules, which look like this. But specifically, we will be focusing on class 2 MHC molecules that present antigenic peptides to CD4 plus T cells. And just in case you don't know what I mean by MHC molecules, MHC stands for the Major Histocompatibility Complex, and these molecules are membrane-bound glycoproteins which function as specialized antigen-presenting molecules that form stable complexes with peptide ligands in order to display them on the cell surface to be recognized by T cell receptors. For our purposes, it's good to know that class 2 molecules are made up of two non-covalently associated glycoproteins, the alpha and beta chains, and that the peptide binding groove falls in between alpha 1 and beta 1. And you're probably wondering at this point, why is this even important? Well, considering how antigens need to be processed and presented to cell surfaces, these class 2 MHC molecules participate in one of the pathways used to do just that. And speaking of pathways, there are two pathways I wish to briefly mention. One involves class 1 MHC molecules and the processing and presentation of endogenous antigens, or antigens found within the cell. The other involves the processing and presentation of external antigens and class 2 molecules, which is precisely what we're going to look at. This one ironically is sometimes referred to as the endocytic pathway, but for our sake, let's refer to it as the exogenous pathway. And no, unfortunately, this has nothing to do with exo. So to simplify what is happening in general, there is an uptake of the antigen is degraded into peptides, then a peptide binds to the MHC molecule forming a complex, and then it's taken to the surface for presentation. Pretty easy, right? Right. So specifically, most APCs typically internalize exogenous antigens by either phagocytosis, where material is eaten or engulfed by the cell, or receptor-mediated endocytosis, meaning that the material binds to specific surface receptors. When the antigen is internalized, the antigen travels via transport vesicles through several acidic compartments containing hydrolytic enzymes. Here is the listing of those compartments and their pH characteristics. All the while, class 2 molecules are synthesized within the rough endoplasmic reticulum and are joined to a protein known as the invariant chain, which prevents the binding of endogenous antigen peptides and helps in directing the complex to the compartments containing exogenous antigen peptides. As the class 2 MHC molecule travels through the Golgi to the compartments, the invariant chain degrades, leaving a small fragment known as the class 2 associated invariant chain peptide, or CLIP for short. CLIP continues to bind to the class 2 molecule at the peptide binding groove, preventing early antigen peptide binding. In the late endosome compartment M2C, the antigen is degraded into peptides, which binds to the class 2 MHC molecules that are transported by the vesicles from the Golgi complex to the late endosomes. In order for the antigen peptides to bind, HLA-DM, a non-classical heterodimer class 2 molecule, catalyzes the removal of CLIP in exchange for an antigen peptide within the M2C complex. It is worth mentioning that another non-classical class 2 MHC molecule, HLA-DO, inhibits HLA-DM, but the purpose for this is currently unknown. Once a peptide binds, forming the class 2 MHC peptide complex, it is transported to the plasma membrane. So normally it takes 1 to 3 hours for the antigen to migrate through the pathway and be presented to the cell surface as a class 2 MHC complex, but fortunately for you, it only took about 5 minutes for me to explain. Hopefully, this was enough to help get that chip off your shoulder.